So this is part 2 of our weathering videos, and in this video I'm going to be talking about chemical weathering. Chemical weathering is when rock is broken down, but the material that it's broken down into has a different chemical composition than the original rock, which in our last unit we called our parent rock. The first type of chemical weathering that I'm going to discuss is what we call hydrolysis. It's when water dissolves rock. And water has ions, which we call hydrogen, and the hydroxyl ions, which is the OH there, that will combine with those minerals and break them down into something different. For example, here I have feldspar. Feldspars that we find in granite that help keep that rock together can be broken down by this hydrolysis by water and will change into a clay which is called kaolinite. The second kind of chemical weathering is what we call hydration. And hydration is really just the breaking down of minerals by the absorption of water. And the pictures that I have here is of a mineral called anhydrite that when it comes into contact with water, it will break down into gypsum, which is a mineral that we just observed during our mineral unit. And if you look at their chemical formulas, their chemical composition, anhydrite has a CaSO4 chemical composition, and gypsum's chemical formula is CaSO4 plus 2 waters. So here you can see that anhydrite will be broken down into gypsum, and gypsum's chemical formula with the addition of water. Oxidation is another form of chemical weathering, where oxygen in the air and the water attack minerals that are iron-containing minerals and rust them. And in the photo you can see that reddish hue that we often see in metals, on cars and so on, when they've been exposed to the oxygen over a long period of time. Carbonation is the next type of weathering that I'm going to be talking about. It's when carbon dioxide in the air combines with water to form a weak acid. And when that weak acidic rainfall reaches back to the surface and hits minerals like calcite, which are in limestone, it will begin to dissolve it. And here in this photo you can see that I have this chemical formula there for you to look at. And you can see the carbon dioxide plus the water in the air form that weak acid. And when that weak acid comes into contact with limestone that has that calcite, it will change into something different. And when that happens, empty spaces below the surface will occur, which we call caves. And that is because of this whole process of carbonation. House caverns is a very popular cave that people will go and look at. Also caves, people will go and explore all different kinds of caves. And sometimes these voids that are in the limestone, the material on top of it will actually fall into that hole, and we call those sinkholes. The last thing I'm going to talk about with chemical weathering is acid rain, which is due to pollution. Industries and the burning of fossil fuels can put nitrogen oxides and sulfur dioxides into the air that will mix with water and form very strong acid. And when it reaches the surface, it can do damage. Like in the picture here, you can see the brown spots in the landscape where the acid rain has damaged that life that's there. Also, these can also break down rock as well, but not just the rock, but living things that are on the Earth's surface. So now I've finished talking about chemical weathering and would like you to stop the video and answer the question off to the left. As well, I'd like for you to go back into your notes and finish the statement about chemical weathering. I would also like you to do the 2 Regents review questions at the end of the notes.